Hello dear friends, welcome to the lecture of geometry. We have studied the first chapter as the plane. Now in this lecture we will start the second chapter, which is right line. Right line means the straight line in we are considering three-dimensional geometry or solid geometry. And in the chapter of plane we have seen that intersection of two planes is a line. Therefore a line can be represented as intersection of two planes, or two planes together will represent a line, and that means therefore two equations of planes means the equation of first degree equation always represents a plane, and therefore two equations ax plus by plus cz plus d is equal to 0 and a1x plus b1y plus c1z plus d is equal to 0 together represents a line. So this can be seen that if this is one plane and the second can be considered as this one. See, the intersection of these two planes is this line, and therefore a line can be represented as the equations of two planes together. These two planes together represents a line. And if you consider the coordinate axis, say suppose the axis be denoted by say x-axis, suppose this x, y and z-axis. Now what will be the equation of x-axis? X-axis is the intersection of these two planes xoy and xoz plane, and therefore the equation of x-axis will be represented by equations of these two planes. So x-axis, the x-axis is the intersection of two planes, and the two planes are xoy or xy plane and xoz or xz plane, and therefore the equations of x-axis will be equations of these two planes. Equations of x-axis are, now what is the equation of xoy plane? That is z is equal to 0. Here z coordinate is 0 in this plane, and z is equal to 0. And what is the equation of xz plane? xz plane, in xz plane y is equal to 0. So the equations of x-axis are y is equal to 0, z is equal to 0. Similarly, the equations of y-axis will be z is equal to 0 and x is equal to 0, and equations of z-axis will be x is equal to 0 and y is equal to 0. So these are the equations of the axis, or we may mention this as the equations. The equations of y-axis are, and we use here r because these are two equations. Equations of y-axis are x is equal to 0, z is equal to 0. The equations of z-axis are x is equal to 0, y is equal to 0. So these are the equations of axis. Actually these are the planes. Z is equal to 0, y is equal to 0 is a plane. Z is equal to 0 means this bottom plane, so XOY plane, and y is equal to 0 means this XOZ plane. So thus these two planes together represent x-axis. Here also these two planes, x is equal to 0 is the plane YOZ, and z is equal to 0 is the plane XOY, and that the intersection of these two planes ZY and XY is the y-axis. And similarly, the equations of z-axis are x is equal to 0 and y is equal to 0. So thus basically a line is intersection of two planes, and therefore the two planes together represent a line. Now we will see the different forms, another forms of equations of line in space or in three-dimensional space, and that is equations of the line through a given point, passing through a given point and having a given direction or drawn in a given direction, and the direction is given in terms of direction cosines, the angle made by the line with the xyz, positive xyz axis, and we will obtain the result as to find the equations of the line passing through a point. The point is x1 y1 z1 that we have denoted by a, and having the direction cosines lmn. So we know the direction cosines is the cosines of angles made by the line with positive x, y, z axis. And first here we will draw a figure as, see, these, suppose these are the axes, z axis, x axis and y axis. The axis can be interchanged. We can consider this as x axis, y axis, etc. And suppose A is a point here, and we are drawing this line. This is the point A, whose coordinates are given as x1, y1, z1, and we will consider the direction, having the direction cosines of this line. A has the direction cosines lmn, and we take a point P on this line whose coordinates are x, y, z. This is the point P, and now what we shall do is we shall project this line on x-axis, and that means we have to draw perpendicular from A on x-axis, and let that be AM, and draw the perpendicular from P on x-axis, and let that be N. Further also we shall draw a line parallel to the x-axis passing through A, meeting this Pn at point Q. So we can write the derivation of this equation of line as, let P be a point on the line let P x y z be a point on the given line, on this line, and let AP is equal to R. Suppose this length AP is R. Now we project the line segment AP on x-axis. So projecting segment AP, actually the line is infinite. This line is infinite, only we have considered the finite part of the line, segment of the line as AP. Projecting segment AP on the x-axis, we have. Now what is the projection of AP on x-axis? Mn is the projection. Draw the perpendicular from A on x-axis, draw perpendicular from P on x-axis, and it meets the foot of perpendiculars are M and N, and therefore Mn is the perpendicular, and therefore we have Mn, the length Mn. But this length Mn is equal to length AQ, because AQ we have drawn parallel to Mn. So this is equal to AQ. And what is AQ? AQ from this right angle triangle AQP. Now what is this angle? This will be the angle made by the line with x-axis, because this AQ is parallel to x-axis, and we have the direction cosines as lmn or the general notation for the angles made by the line with coordinate axis are denoted by alpha, beta, gamma, and therefore we suppose the angle is alpha. This angle is alpha. So angle made by the line with x-axis, positive x-axis is alpha, beta is the angle made by the line with y-axis, and gamma is the angle made by the line with z-axis. So therefore this angle is alpha. Now from this triangle, what is cos alpha? You see, cos alpha will be equal to the adjacent side AQ, that is AQ divided by AP, which is R, and therefore AQ will be R into cos alpha, and thus this is R cos alpha. But what is AQ? See, this AQ is same as MN, and therefore, or what is MN? MN will be the difference of the x coordinates of A and P. This is the difference. So because the x coordinate of n is x, that is x 0 0, this is the point on x axis, and its y and z coordinates are 0. So therefore the coordinates of n are x 0 0. What are the coordinates of m? Are x1 0 0, and therefore the distance mn is x minus x1. So that is, this is x minus x1 is equal to r, and we have assumed AP is r. And what is cos alpha? We know cos alpha is L, because the direction cosines of the line are L, M, N, and that means we have L is equal to cos alpha, M is equal to cos beta, and because the angle made by the line is alpha, beta, gamma, and therefore L is cos alpha, M is cos beta. So this is the earlier notation that we know, so there is no need to write it here, and N is equal to cos gamma. So this is that we know, and therefore we write cos alpha as R into L. So thus the projection of AP on x-axis gives x minus x1 is equal to R into L. Similarly, projecting AP on y and z axis, we get as exact similar result, that projection on y axis gives y minus y1. Y minus y1 is equal to, this r length is fixed, and now the cosine, direction cosine will be m here. So r into m, and z minus z1 is equal to r into n. So thus we have these three relations: x minus x1 is equal to r into L, y minus y1 is equal to r into m, and z minus z1 is equal to r into n. Now this will give any point on the line. So as in terms of x, y, z, we have considered x, y, z is a point or any point on the line, and therefore the coordinates of that point will be given by in terms of x, or which is x1 plus r into L. Therefore the coordinates of a point on the line of a point or any point on the line are given by see this set, actually x, y, z, x, and for what is the value of x from this? X1 plus r into L. So that is x coordinate. What is r? R is the distance of that point from this fixed point A. A is fixed point and P is any point. So if you change P point, we will not change A point. A is fixed. P point changes, the distance r will be changing. So x1 plus rl, y1 from this, y1 plus rm, and z1 plus rn. So this will give, this is the set of points, coordinates of any point on are given by this, where r is R is equal to A into P. And now again from this relation we will write the expression for as R from this equation. So therefore we have from these three relations we will consider. And the condition necessary for that is these DCS or direction ratios must not be 0. So these must be non-zero all. So therefore if L, M, N are non-zero, or if none of L, M, N is 0, that is, or this can be written as L into M into N is not equal to 0. So this not be 0, and that means L is not 0, M is not 0, N is not 0. None of this is 0 means no number of these is 0, and if none of them is 0, the product is non-zero. Then we have, now you see from this relation, what is the value of R from this? X minus x1 divided by L. This is R from this equation. And what is the value of R from this relation? Shift this M on this side. That will be y minus y1 divided by M. Both gives the value of R, therefore these are equal. And also R is given by this equation, and that is z minus z1 divided by N. So that's why we have written none of this L, M, N is 0, because if any one of this is 0, then the quantity is not defined. So then we have this, and this is these are the equations of line passing through the point A and having direction cosines LMN. So these are we will denote this by 1. These are the equations of line. These are the equations of the required line. So thus we have derived the equations of line having the condition passing through the point A, x1, y1, z1, and having the direction ratios L, M, N. These are the equations of the required line. So this is our first result in symmetric form, or actually the second result, because the first result we have seen equations of line are represented by two planes together. That represents a line, and these are also the equations of line, which is known as symmetrical form of equation of line. I am passing through the point x1, y1, z1 having DCS LMN. Or for example, if we have find equations of line. Of the line passing through the point, say 1, minus 2, 3, and having direction cosines. Direction cosines we will consider equal. That means what is the meaning of this? If the direction cosines are equal, L is equal to M is equal to N, then the line will make equal angle with the coordinate axis, with x-axis, y-axis, z-axis. The same angle is made by the line, and one relation should be satisfied by must be satisfied by the direction cosines, that is L square plus M square plus N square is equal to 1, and you see this is satisfied. These are LMN values. Square of this these is 1/3 each, and sum of 1/3 plus 1/3 3 times is 1. So therefore this can be taken as direction cosines, and using this, so what will be the equation of the line? So if you have to consider this point as x1, y1, z1, the equations of line are x minus, we will write directly, it is easy to write, x minus x1. What is x1? 1. So it is x minus 1 divided by L. What is the value of L? These are the values of LMN. So 1 by root 3 is equal to, and what is the second equation? Second term, y minus y1. But y1 is minus 2. So minus of minus 2 becomes plus 2. So it is y plus 2 divided by 1 upon root 3. And the next will be z minus z1, means z minus 3 divided by 1 upon root 3. So these are the equations, but this can be simplified. We can divide by root 3 throughout the equation, and this denominator cancels throughout. So therefore that is x minus 1 is equal to y plus 2 is equal to z minus 3. So these are the equations of the line passing through this point and having these as the DCS. So in this way we can use this symmetrical form to obtain the equation of line passing through a point and having the given direction ratios L, M, N. Now instead of direction ratios, direction cosines, if direction ratios are given, then what will be the equation of line? So we write that as a note or remark. We know what is the relation between the direction cosines and direction ratios. So direction cosines we have denoted by LMN, and the direction ratios we denote by ABC. So and these are in proportion. The DCS and DRS are in proportion. That means L upon A is equal to M upon B is equal to N upon C. This is the relation we have in in the DCS and DRS, and therefore these are the proportions or ratios, equality of ratio, and thus if you replace by LMN by ABC, the relation holds good, and thus this here we can replace LMN by ABC. The equation is equations of line will be obtained. So LMN can be replaced by ABC because LMN are proportional to ABC, and since the direction ratios ABC are proportional, ABC of a line, proportional to direction cosines. In short, hereafter we will denote this by DCS, DRS, direction cosines LMN. So we have equations of line. The equations of the line passing through the same point, passing through the point x1, y1, z1, and having DRS A, B, C, R, and I shall write it here that R x minus x1 divided by A, y minus y1 divided by B, and z minus z1 divided by C. So this is these are the equations of line passing through the same point x1, y1, z1, and but having the DRS ABC. So this will be our second equation. Now an example will be simple for this. It is direct. So equation of a line passing through the point. See, if the point is say 3, 5 and minus 6, and DRS are given as, now DRS there is no condition, you can consider any three numbers as DRS, and suppose the DRS are say 2, 1 and 0. 0 cannot be considered because we have the condition, the DCS and DRS must be non-zero. This is not defined, so instead this we will consider DRS as 3. So equation of line passing through this point and having DRS through point this having DRS are the equations of line. Equations of the line passing through the point and having DRS are by this. See, x minus x1, here it is 3, divided by a, it is 2, a, b, c, these are the values of a, b, c, and is equal to y minus y1, that means 5 divided by 1, and z minus z1, it is minus 6, and minus of minus becomes plus, and c is 3. So in this way we can write easily the equation of a line passing through a given point, and if the DCS are given or DRS are given, the equation has the same form. Now one more equation we will consider is equation of a line passing through 2 points, given 2 points, equations of line. So that will be our next result of equations of line. So equations of the line two given points. So we know 2 given points are sufficient to fix a line, and suppose that means to find equation of line, equations of the line passing through the points, and we will consider the points as x1, y1, z1 first point, and second x2, y2, z2. Now how this equation can be written? Now it is very easy to write the equation. So what we shall obtain is the DRS of this line. Now what are the DRS of the line passing through these 2 points, x1, y1, z1 and x2, y2, z2? Yes, the DRS will be, if the coordinates are given, the DRS we know is the difference of the coordinate. That means x2 minus x1, y2 minus y1 and z2 minus z1 will be the direction ratios of the line. So the direction ratios or DRS of the line are x2 minus x1, difference of x coordinate, y2 minus y1, z2 minus z1. So once the DRS are known, now we can use the earlier result. The line passes through the first point or the second can also be taken. So this point and having this DRS. So therefore, and see, these are the values of A, B, C. So in place of A, B, C, we simply write x2 minus x1, y2 minus y1 and z2 minus z1. So therefore, the equations of the line are x minus x1 divided by x2 minus x1. We may consider this point also, x minus x2 divided by x2 minus x1. Any point can be taken because the line passes through both the points, and is equal to y minus y1 divided by b, that is y2 minus y1, and z minus z1 divided by z2 minus z1. So this is our third equation of line. So thus first we have seen the unsymmetrical form means two planes together represent a line. Next we have seen symmetrical form means equation of a line passing through a given point and having the DCS, given DCS, and the similar result is equation of line passing through a point and having the given DRS that we have seen. And here this is the equation of line passing through these 2 points, or this is very easy to consider. Equations of line, equations of the line passing through the points. Say the points can be considered as minus 4, 5, 1 and 2, 3, minus say minus 5 r. Directly we can write these are x1, y1, z1, these are x2, y2, z2. At numerator what we should have to write x minus x1 means x minus minus 4, which will be x plus 4, divided by 2 minus minus 4, x2 minus x1. See this, x2 minus x1, this is x2, this is x1, and next is y minus y1. We are considering this as x1, y1, z1. So y minus 5 divided by y2, that is 3 minus 5, and is equal to z minus 1 divided by z2 is minus 5 and z1 is 1, or that is, this can be simplified. So it is x plus 4 divided by, this is 2 plus 4, 6, and this is y minus 5 divided by minus 2, and this is z minus 1 divided by minus 6. Now this can be divided, actually multiplied by minus 2 throughout. So if you multiply by minus 2, then that means we have to divide by the denominator by minus 2, or that is x plus 4 divided by, if you divide it or divide simply by 2 or multiply throughout by 2, and this gives 2 divided by 6, that is 3. 2 divided by minus 2, that is minus 1, and here 2 divided by minus 6, that is minus 3. So these are the equations of the line. So thus in this lecture we have seen equation of straight line, how a straight line is expressed in terms of two planes, and then we have seen the symmetric form of equation of line and 2-point form of equation of line. Remaining part we will continue in our next lecture. Thank you.